Hello. Today we are working with 4.2. 4.2. All right. And we're going to be doing page 158 in our blue book, numbers 4 through 10 even. Okay, let's get started. The guidelines tell us that on section 4.2, we are dealing with discrete and continuous graphing of a linear function. So we need to be able to determine the difference between discrete and continuous, okay? Discrete is when we can only have it in whole amounts, like you can have a whole shirt, or you can have a whole bicycle. You can't use a bicycle that's a half of a bicycle, okay? A whole car. So when we're counting X and we're talking about cars or a bicycle or something that requires a wholeness, then we identify that as discrete because they come in singular units, whether you have 1, 2, 3, 4, 5. But when you speak of continuous, continuous is something that can be in parts. You can have a whole and a half, like a candy bar, like a cake or a pizza, okay, or inches or miles, okay? So these are things that you can do in increments between whole values, all right? And you can have intervals in between. So that's one way of determining continuous and discrete. The other way is when you look at a graph, when you're speaking of continuous, continuous has a solid line connecting all of the dots or all of the coordinates. But when you think of discrete, discrete only has the coordinates, does not connect. Okay, so then that means it's an individual thing and it is declared discrete. All right, so there we are. That's my summation of discrete and continuous. So let's take a look. On page 158 in our textbook, it asks us to determine if it is discrete or continuous. For number 4, you see the distinction of each individual amount. So therefore, we call that discrete. So we're going to put a discrete here. Okay? All right. Here on number 6, they ask us to graph, and then they want us to determine if it's discrete or continuous, okay? So in a case like this, and let's take a look. We're talking about years. Years can be broken up in a year, half a year and a half, and so on and so forth, and then compared to our feet. So in a case like this, we would say that this would be continuous. You know, Miss Jones is not a speller, so I always second guess myself. So, all right. Next, when we talk about number 8, we're talking about hats. Okay, and our discrete and continuous is determined by our X, by the way. Okay, so when we talk about hats, we don't go around wearing a hat or a hat and a half. So therefore, in this case, we have a discrete situation. Okay, all right. And so I'm not going to trouble trouble myself with the graphing because I think you know how to graph, okay? Right now we're just trying to be clear that you understand the difference between discrete and continuous. All right, let's move forward on number 10. On number 10, we're talking about yarn, okay? And so the question is, if we're talking about yarn here, when we buy a spool of yarn, we buy the whole thing, right? And so therefore, clearly, we have a discrete situation, okay? All right? And so now, from there, they ask us to plug in. If we plug in 0 here, then that would make this whole answer 0, and we'll be left with 40, okay? So let's take a look. 40 minus 8.5 times 0. That would cancel that out, and so the answer would be 40, okay? On the next one, what if it is 1? So that y is equal to 40 minus 8.5 times 1. So then 40 take away 8.5. We would have a 5, a 1, a 3. Okay, so we have a 31.5. That would be Y, okay, for there. All right, so we got 31.5, okay. If it is 2, then we would have a 23. And if it is 3, we would have 14.5, okay. So you understand the concept, all right. And that's the answer or the lesson for 4.2, okay. See you in the morning. Bye.